Graceful Restart. So a bit of acronyms that we are going to use as a reference today. So most of them were already covered. So GR means Graceful Restart in here. We are going to talk about devices that are keeping their FIB, their forwarding information base, so where we store all the routing and egress next hop information in the ASIC. And we are going to talk about obviously the RIB as well for the protocols, BGP, end of RIB marker that will be exchanging for BGP messages updates between BGP speakers. And most of the part is about Graceful Restart. So we are talking about a restarting speaker. And to simplify, we call it a Graceful Restart restarter, and a receiving speaker, which is an helper. So those two acronyms are well known. Those two wording are well known for Graceful Restart in OSPF, for instance. So let's get to an overview of Graceful Restart. So this is a mechanism to freeze the network data plane while the network control plane is being restarted. So the overall purpose of that is obviously to avoid any traffic interruption in the network. So the restarter router will notify the peers, the adjacent peers, that the routing process has restarted, requesting the neighbors to really not to remove any FIB entries pointing to the restarter that is actually the next hop for such routes. And those routes will be marked as stale on those neighbors. So when the restarter router has completed that process restart, it will send a completion notification to those neighbors so that the routing protocol peering on each of those is restored as a nominal state. So this is the purpose of Graceful Restart. So before 10.6, the Graceful Restart capability was supported on OSPF v2 and v3, address family IPv4 and IPv6, but not on EVPN. So as a consequence, well, for the switch restarting the process, this is everything is getting cleared in terms of route, and when the BGP session is restarted again, you'll have to obviously learn all the routes back. For the neighbors see the BGP session getting down, the routes are cleared, and when the BGP session is established again, all the routes needs to be learned again from the peer, and all the EVPN routes that were received on the neighbor before from the external peering, for instance, has to be sent again to the peer that was restarted, as if it was a fresh BGP session. Now with 10.6, we have that availability to have Graceful Restart for that EVPN, for those of EVPN routes, removing any traffic interruption. And we will see in the demonstration that EVPN traffic is not interrupted when we have the HP routing restart. Very nice. Huh? So the use cases, what are they? And especially when do we have to consider Graceful Restart? So there are really 4 use cases that I described here. The first 2 are very related together. So there is one which is the VSF commander switch failover to the standby VSF switch. So for instance, due to a power off or to a reboot of the VSF commander. So the HP routing process is stopped on the VSF, and the routing architecture module on the VSF standby needs to move the HP process that is dormant to an active state, and that in a very short time. So something like before 3 or 5 seconds after the switchover. Right after that process has been restarted, a BGP open message is sent to the peer. So there is a new TCP socket being established, and that TCP connection getting established and triggered, received by the peers, is actually interpreted as a Graceful Restart event. And so that message, that new TCP socket connectivity has to come before the hold timer so that we can have the hold timer, the BGP hold timer, before the session get dropped. So for a chassis, the 6400 and 8400, this is exactly the same when we have a management module failover, right? So the active management module is either removed or there is a software switchover between the active and the standby. So as the active management module stop, the standby again will kick in the HP routing process for that process to start a BGP open message, but before a TCP socket, and that TCP socket again is interpreted as a graceful restart. So that will avoid any route withdrawn on the peers to the network. HP routing crash handling is the third use case that is very useful. It can happen that there is a problem on the software, so the HP routing process is crashed and restarted. So you can do that as a demonstration to people. It's actually very efficient. So you can just kill the HP routing daemon, and there is the infrastructure daemon systemd that will be responsible in restarting that process immediately. So and restarting that process will obviously kick in a TCP, a new TCP socket establishment that will be interpreted again by the peers as a graceful restart event. So that when they interpret that event, the FIB is no longer touched and maintained on the neighbor, so that there is no traffic interruption. And the last use case is actually not supported right now. So this is when you have a true ISSU in-service software upgrade being performed, where the data plane is partially maintained. For instance, you are refreshing and updating processes inside the CX one by one, and there is in consequence a very high interest for graceful restart, because it's likely that the HP routing daemon is going to be upgraded in those ISSU processes, so that we need the graceful restart capability to avoid any control plane impact. So that is those use cases very important to note. So clarification, consequently, and reminder, graceful restart does not help at all for non-ISSU upgrade. So if you have a non-ISSU upgrade, that will not help. Graceful Restart has also no impact and no effect on the VSX update software orchestration. During that mechanism, this is graceful shutdown that is being used. Okay, let's move on with details. So in terms of support, we support Graceful Restart on all platforms except the 6200, where we do not have much support for those processes, those routing process. And now what I highlighted in orange is obviously that we are now supporting. Yeah. And then we have the obviously now that support for EVPN address family. Regarding the scale, we are supporting for an helper, for instance, the reception of all those new TCP socket and open message to help the restarter up to 256 restarter at the same time. So up to the entire possibility of BGP neighbor that is today a scale of 256. Next is about details of those open message. So how we negotiate with the peer that we have the ability to perform graceful restart. This is done during the BGP open message. So we have in the open message capabilities optional parameters that are exchanged. So here this is the switch 2 that is sending that capability to switch 1, and inside that you see capability restart. We sent as well the timers. So for instance, this is the graceful restart timer, which is the max time you have to wait for the restarter to come up. If the restarter does not come up in terms of control plane establishment before 2 minutes, here as a default parameter, well, you will tear down all, you will clear out all the routes that were stale coming from that switch that is rebooting. So we'll go back to that, and you see there is the address family that is impacted by that is where we want to have graceful restart capability. Yeah, the AFI and SAFI is provided here. So we have that status in with the show BGP L2 VPN neighbor IP address of the neighbor, where you have the graceful restart enabled capability. So we'll get into the graceful restart enablement right after the slide. We have the graceful restart default timer here that you can change, as well the graceful stale path time. So this is the max time to hold on before refreshing the peer routes, the peer that is restarting. So you will maintain those up to 5 minutes, again default value, up to 5 minutes the stale path in the routing table before um, uh, any clear out of the routes if the neighbor does not refresh those routes. So this is the time you hold those routes unchanged in the fib. And the graceful restart capability that has been advertised and received between the two peers. Let's move on with the graceful restart mechanism as such, already explained, but let's dive more into details. So BGP initiates a graceful restart mechanism when you have an active control plane switchover. And also the mechanism is also when the switch is acting as a graceful restart aware device, or also well known as a graceful restart helper. So that helper is notified by the peer when there is a transition for the control plane, and so that it will take associated and appropriate actions for the routes that are becoming stale on and with the configured timer that we were talking about before. So when a BGP restart happen on the peer router, the routes that were in place in the forwarding table are marked as stale. So the forwarding state is completely preserved. There is a independent operation on the control plane and the forwarding plane. So on the restarter side, the BGP start to establish a new session after the restart for all the configured peer. So the neighbors, the helpers, will see a new TCP socket connections on port, the BGP port, which is 179, coming while an existing BGP session was established before. So it's the status of the BGP session was established. So as receiving a new socket, it will be an indication that the peer has restarted, and this is a graceful restart event. So just to explain you overall that the graceful restart mechanism is not a notification that is done proactively before the HP routing process is restarted. This is done after the control plane has restarted, thanks to this interpretation of the BGP session new establishment. So very important to understand that. Next is about how this is triggered here, just as a respect of what I mentioned before. So switch 2 is restart. So the process for HP routing is restarting. It sent a new TCP socket. So you have that SYN message here on that port. And on the helper, on the receiver of that, you have the session was already established. Here you can see it was established for more than 1 hour. So as receiving this, switch 1 will detect that the routing protocol on switch 2 has restarted. But how you compare that new open message, BGP open message, to something that is a new a reset of a BGP session, for instance? How we compare that? Well, that event, that graceful restart event, is really with the fact that you have a restarter bit and a preserve forwarding state bit set to 1 in the BGP open message, right? So these 2 bits is the indication this is a graceful restart event that is sent by the restarter. So how it's being exchanged in the BGP open message this time. And I see a chat, and yes, we are going to cover that, Somia, in a while. In that BGP open message, you see again the graceful restart capability. You see here there is a restart state yes and a preserve forwarding state yes. And all of that in the context of the EVPN address family. Okay, so this is really the graceful restart open message that is being sent. Effect on the neighbor, on the helper, is here I do a repeat of the show BGP L2 VPN summary just to check the establishment state on the BGP session. So you can see here that one was up, and then that session is getting cleared, and the new session, a new TCP socket and a new BGP session are established. If you look at the log, you will see in the events list that there were a peer up and then a peer down. So there is an error code that is being seen here in the event. It's not very explicit, so we acknowledge that and we will make an improvement later on that message so that it's very clear when you check about the event. So stay tuned on that. We'll probably in next releases we will try to make that a bit more efficient in terms of understanding. Effect on the BGP neighbor as well. Here you will see on the data, for the data plane, we have the switch one that will flag all those routes entries for route type 2, route type 5, whatsoever, route type 3, will have a flag that is SS min stale here, right? So that those routes are maintained in the FIB. Obviously, there is absolutely no impact whatsoever on the routes coming from the other peers. So here, switch 3 is not restarting at all. Okay, it's steady state. Just to let you know that switch 1 in is RIB, you will see stale for the restarter and valid entries as if nothing was. So there is no consequence on the other peerings, obviously. On the routing message updates that are coming as well from switch 1, because switch 1 has to do further processing, and when the BGP session has been restarted, you have switch 1 that needs to populate back switch 2 with the initial route table, the complete route table for the network. So switch 2 has to relearn everything, right? So for that, we have the processus that is to send everything, and there is an end of RIB marker that is at the very end of the initial routing update being processed, so that there is a completion of the route learning sent between switch 1 and switch 2. So this is the end of the Graceful Restart process. And you see that end of RIB marker, depending on the address family, it's not the same all the time. So here, for the VPN address family, there is MP unreached NLRI entry that is getting used, okay, with no withdraw route, which is a meaning that this is the end of RIB. For other IPv4, IPv6 unicast address families, for instance, the head-on RIB marker is not exactly the same. It could be an update message with the minimum length, for instance. So specifically for EVPN, this is the end of RIB format for the marker. Stale management. So how you manage, how we will manage the fact that the route are the status of the route is from stale to normal. So under normal condition, the stale flag of those routes that were coming from switch 2 will be removed if the corresponding route update is received from the restarting speaker on the neighbors. The neighbor will purge all those stale routes after the restart time, so which is again 2 minutes by default, but it can be extended. If after that restart time expired, and if the restarting period does not establish the BGP session before the expiration of that timer. Okay, so there is two things to consider. First thing is that the BGP establishment must be done before the restart time, otherwise stale routes are removed. And also the neighbor will purge those stale routes after the stale path time. If the restarting peer does not send in time, so switch 2 does not send in time into switch 1, the route updates before the expiration of that timer. Those two timers, restart time and stale path time, are starting at the same time when there is an the first BGP open message with the graceful restart bits sent by switch 2. So process completion, we already discussed a bit of that. On the restarter has to reestablish all the BGP sessions to all the neighbors he may have. And obviously will delay the best path calculation for all the EVPN routes after receiving an end of RIB marker from all the peers. And he will also generate updates to its peers, which are the helpers, and send also on his side a completion with end of RIB marker. On the BGP neighbors, so for the helpers, they are receiving the routing update from the restarting speaker, and they will remove the stale flag on those refreshed routes, and they might purge any remaining stale path after having received the end of RIB marker from the restarting peer, or when the stale path timer expired. Swati, maybe you want to to cover the impact on the associated EVPN VXLAN tunnels?
Yes, yes, thanks. So if on graceful restart, if the restarting speaker is a VTEP, then what we are trying to say is there is no EVPN impact, which means that there are no tunnels that will get deleted. All the tunnel VXLAN tunnel pointers are kept unchanged in the ASIC for data plane continuity. And although the protocols, all the underlying protocols, let's say if OSPF is used as underlay, it would also get restarted along with BGP. So although all the protocols are restarted, the OSDB route table will be kept unchanged for both underlay and overlay. And while the host routes, those are the route type 2 EVPN routes, are marked as stale, but the associated MAC address table is maintained. This finally means that whatever the changes that EVPN does, like for route table having /24 routes for type 5 or /32 routes, and the MAC table and the tunnel endpoints, VXLAN tunnels, all of them are kept unchanged for data plane continuity. There would be no change in DB.
Okay, thank you. So in terms of configuration now, so BGP graceful restart is enabled by default, and we cannot disable specifically for BGP that capability. So you can disable graceful restart globally. So that's a global parameter that will affect all the protocols, not only BGP, but also SPF and all other protocols that handle have graceful restart capability. So this is a global parameter. But for BGP as such, inside the BGP process, there is no way to disable that. The graceful restart timer are configured inside for BGP inside the VRF, the global the default VRF, okay, in the global BGP configuration part. It's not per address family, it's globally configured and for all the VRF. So the two BGP graceful restart timer has to be configured. So the restart time that which is the maximum time to wait for the restarter to come back, and the stale path time that we explained before, which is the maximum time to hold before refreshing any peer routes. How to change those timer? You get into the BGP graceful restart with those two timer in the right after the definition of the router BGP process of the autonomous system. Okay, best practices. So graceful restart is enabled by default, and again, specifically for BGP, it cannot be disabled, but it would be disabled for if you decide to disable that globally for all the protocols. However, that really provide the benefit of seamlessly restarting the HP routing process. So it's very recommended to keep that default enablement for graceful restart. And this is useful for this reason. If there is if this is not a chassis with dual management module, if this is not a VSF stack, there is still a benefit of using Graceful Restart for that. Combination of Graceful Restart and BFD. So if we consider using hardware BFD with echo function and BGP Graceful Restart, so that combination works well because the BFD echo function would be for the peer would be just a loopback accelerated by the ASIC, so the control plane restart will not affect that. If we are using software BFDs, like for instance for IPv6 right now, and Graceful Restart, maybe requiring some specific attention and testing to guarantee the hiability of the overall solution. Indeed, BFD, if you have a control plane switchover, so here, for instance, this is a chassis here that our VSF stack with the switchover between the active control plane and the standby control plane. Switch one, if there is a very aggressive BFD timer, switch one may detect that before the echo is being in software is being replied by this guy who with the control plane getting rebooted, that guy may detect connectivity failure before receiving a new TCP session establishment. So it's something that it's a niche case, but have to be considered if you see in the configuration very aggressive BFD timers.
So with EVPN GR troubleshooting, the very first step for us to go about is to check whether the sessions are BGP sessions are in established state after GR. So right after GR, it's a reset session, like Vincent was explaining before. It's a reset session. First and foremost should be to check the sessions have come up, and you can also check the same thing in the log where we are logging the open message packets from where to where, the local address and the remote address and other details along with that. And also we in the event we display what which peer has changed to what state. As you can see here, peer so and so has changed to established state. So these informations we can check in the BGP debug event. The next most step is let's say the underlay protocol in this example or the demo that I'm going to show. Usually the underlay would be OSPF. So underlay route whichever is there must not be changed, must remain unchanged on Graceful Restart. Now when the HP routing is undergoing Graceful Restart, it means all the protocols underneath are going Graceful Restart along with that together. So which means even OSPF route should not get deleted. If the deletion of underlay route happens, it means that connectivity to the VTEP IP, the next hop, is lost, and hence subsequently it leads to deletion of all tunnels, then IP routes and MAC, everything gets deleted, and maybe it gets re-added as soon as the OSPF comes up, the underlay comes up, let's say. So, but for this amount of time, you can see the traffic disruptions, whichever is there. So maintaining the underlay route state is very important. Next thing is if after GR we have to check that EVPN routes whichever were previously there are received via we can check via show BGP L2 VPN EVPN command. This is a command which says the next hop and the type of the route which is received. Since this is the one which I'm highlighting here is the received, I mean the one this guy is generating, leaf one is generating, but on the top you can see that it is IBGP received route, which means that it is received from the peer. So such routes should be checked whether we have received or not. In case those routes are not received, as part of our stale management, we would clear those routes. So it is important to check whether the routes are received. This is what I was talking about before. Now what we do is on the restarting speaker, when the restarter sends out all the receives all the updates from the helper, let's say. So it waits for certain amount of time before it kickstarts its best path calculation. That is, it should receive EOR from all of them. and then it starts it updates. But if it has not received any route updates for that stale path timer, it would delete all those. It would handle stale path management. As part of our show log, fast log, we show the EVPN dump with stale path management, how it is done. So you can grep for this stale and check that uh, the after the stale path timer has expired, if there are any entries that are getting cleared as part of that, be it tunnels, be it MAC or route. Route can be anything, as you know. It can be a host or it can be a prefix route. So as of now, as you can see, there are no stale entries which are getting deleted, but this is a place to look out for. In case if you see that depending on the scale, let's say the route updates are received a little later than the stale management timer. So it one of the possibility is that we can check by increasing the stale path timer depending on the scale and check if it resolves the issue. So this is a place to look out for. One more thing is the restarting speaker, when he is going to an GR, it should not in any way affect on the other remote VTEP. So remote VTEP, on the remote VTEP, there should be no deletion of tunnels, MAC or routes, or it should remain unchanged. All of the entries should remain unchanged for you to see no traffic disruption. So that is one more key point here. So these are this is how we dump the routing tables. We are basically interested in three tables. OSDB client dump route. Here you can see that uh, whether it is a BGP route, whether it is an OSPF route, and you can also check for the UUIDs after and before the GR. So this is the route, and this is dumping of tunnel endpoint, and this is dumping of MAC. So these are the three tables we are exclusively interested during GR. If we are in live debugging sessions, then for higher scale, during GR on both restarter and helper, this command can be used: debug db rx table and the table name, to see just the monitoring the incremental changes. um, if you use this command for lesser scale, like OSDB client monitor command, what it will do is it will initially dump everything in first shot, and then it gives you the incremental changes, which may not be feasible for higher scales. Hence, you can go with this command for higher scale, so that it gives only the incremental changes. And the tables are these: MAC, tunnel endpoint, and route. Um, and they are case sensitive as well. And you can monitor for any deletions or re-addition happening on these tables. And these changes, if there is any changes happening, you can see using show debug buffer. And specifically, you can check for module db also. I shall show you that in the demo. For lesser scale, anyways, if the scale is less, you can always go and monitor via OSDB client monitor table name. So this is during live debugging. So let's go into the demo. So before we get into the demo, I shall explain what is the topology being used. I have spine and two leaves here, and there are two hosts which are connected on same VLAN on the same network, 110.0.13 and 110.0.12. And there are two other hosts which are on disjoint subnets. Basically, one is on VLAN 20 and the other is on VLAN 30. So to communicate between these two, I would use only Tie5 prefix routes because they are on the disjoint subnets. And the ones which are on the same network, I could use host routes, the /32 routes, for the ping to go through. So, so this is a network that I have 110.0.0.16 with VLAN 10 and 120 on VLAN 20, and this is for VLAN 30. So this is the overall topology. See, this is my topology which I'm using. I have two 8325s. Spine and leaf 2 are my 8325s, while my leaf 1 is an 8400. So this I'm going to do a redundancy switchover on 8400, which will eventually trigger graceful restart, and then we'll see how the traffic gets affected. So this is the spine configurations which I have. I'm using the router BGP. This is iBGP, same AS. So so here my spine is a route reflector, and the underlay that I'm using is OSPF here. So as you can see, there are two sessions established under L2 VPN EVPN address family. Okay, now this is my 8400 active uh, so this is a configurations for leaf 1. So I have two VNIs, VNI 10 and VNI 20, and I have one L3 VNI which is present. This is where I have VLAN 10 and VLAN 20, and routing underlays, as I told you before, it is an OSPF present. So the BGP configurations are pretty simple. Here I have remote AS update source and activate, and the send community to send out our route targets. And I've used redistribute connected so as to generate a type 5 route. Okay, and this is the interface VXLAN VTEPs. I have two tunnels. One for L2 VNI 10 and one for L3 VNI 10,000 on VRF red. And as you can see under show IP route VRF red, I'm seeing two EVPN routes. One is my /32 route, which is coming from the other end, that is for VLAN 10. And this is one more type 5 route. This is coming from /16, that is a type 5 route. I also have MAC addresses, which is present EVPN MAC address. And as you can notice here, I have not used a redistribute host route under VLAN 20 because VLAN 20 and VLAN 30 are on disjoint subnets. So redistribute host route is not mandatory here. I could do just ping using the type 5 route alone, but here I have used the redistribute host route. So so let's see the route. You can check the routes via this show BGP L2 VPN EVPN command. As you can see here, since because of the redistribute connected, so I'm seeing type 5 route for 110.00 and 120.00. Similarly, I'm receiving those such routes from the VTEP leaf 2 for 110 and 130. So these are the type 5 routes and these are the type 2 routes which are seeing above. So let's see the leaf 2 configurations. Leaf 2 configurations is also similar to this. So instead of VNI 20, I have VNI 30 here, and rest of the configurations remain same. Uh, so these are the two tunnels which are present here. I'll show you the show IP route output here. So 13 is the other end's host, which is coming as a /32 route, and this is the other end's VLAN 20 is connected route, which is coming as a /16 route on the other end. So let's just go through the host configurations. So this is my 110.0.13, which is on leaf 1, host 1 connected to VLAN 10. I have configured active gateway IP for all of them. And I shall be pinging during GR test case, I shall be pinging the other end with same network, that is 110.0.12. Okay, this is my leaf 1 host 2 on VLAN 20. So if you're seeing this 120.0.11, what I'll do is I'll ping the disjoint subnet, which is 130.0.11, and these two are the other hosts. Leaf 2 host 1 on VLAN 10, and this is leaf 2 host 2 on VLAN 30. So this is a disjoint subnet which I was talking about, 30. So from here I'll ping 12, and from here I shall ping 30. So leaf 1 H1 is pinging using a /32, and this is pinging using the /16 route, type 5 route. Okay, so I'll just try to capture the TCP dump directly. I shall show you the Wireshark as well. So let's start with this. So before this is a standby, I have collected all this three tables output actually: route being BGP and OSPF, and then the MAC table and the tunnel endpoint table, so that we can compare the UUIDs once the GRS hit. Let's do a redundancy switch over now on 8400. Let's start pinging here. So we will monitor whether there is any loss during the graceful restart which is happening. So first and foremost thing that we do is to check whether the sessions are up. As you can see, the session is re-established. The timer is reset here, re-established. Let's see the route are present. There are two routes, which is already there, 12 and the one with 16. Okay, and let's see whether the VTEBs are up. VTEBs are still operational, and we should also check whether the OSPF route is intact. It is intact. So if there is any deletion in this, ultimately this would get deleted and re-added. So for that amount of time, you could see the traffic loss which is present. Here you're not seeing any traffic loss. Let's stop this. Let's see if there is any open message captured. Yes, it is here. So this is the one that is received from Spine, who is sending. This is from Spine. Okay. So since this is not restarting, he's not setting the forwarding state to yes. He's just setting it to no. Now let's see the one which is triggered from leaf one. This is from leaf one. As you can see here, for this address family, forwarding state preserved is set to yes, which means that I am this 1.24 is saying to the peer that I am restarting. So please preserve the state so that he maintains all the status. So whatever the routes are received from 1.24 is marked as stale. And once the routes are received, he will mark it as valid routes. So this is the one. So let's see how long the sessions are established. It's already established with 2 minutes 10 seconds. I shall show you the fast log and the stale logs, whichever we are printing. If you can see here, this is the initial start when the graceful restart has hit. We would mark entire entries to be stale for whichever the tables that we are interested or we populate or we are responsible of. And then we start the stale timer of 300 seconds. You already know that stale part timer default values 300 seconds. Once we get the routes, we mark them valid. But after the stale part timer has expired, we see what all the routes are still with stale flag set, and we would delete those routes. So this is still going. As you can see, there is no loss. If there is a loss, we would see dot. So that is why I've given the aggressive pink here. Here also you can see no loss. In the meantime, let's check the open message, how it would look. This is from 24 to 22. This is my leaf 1, which is sending. As you can see here, capability graceful restart. Restart bit is set to yes for the Safi, and then the flag preserve forwarding state is also set to yes. So this is how an open message is sent. Once the open message is sent from 22, that is Spine in my case, would send all the route updates if you can see, and the last packet would be the AOR, end of RIP. If you see here, MP unreached NLRI with the 0 withdrawn routes. This is the EOR for EVPN address families. EORs are specific to each address families. And from 24 also, once he receives those EOR from 22, he is generating all his updates. And at the end, he shall send a similar update message with empty NLRI, unreached NLRI with withdrawn routes to be 0. So this is how he sends back. Now, even if you're seeing there's no loss which you're seeing here. So what we will do now is we will just capture the same output. This was before GR. Let's capture it now after GR and check if there is any change that is going on. As soon as I highlight, you could see that above it is marked here at this point. You can see that UUIDs, whichever is there, is unchanged here. 5072 F1. The EVPN entry is still intact, and the tunnel endpoint has not changed here. And also one more thing to notice is on the other end, I have run the monitor command in the background. I've run monitor of all these three, route, MAC, and tunnel endpoint, and I see no updates that are coming from the DB updates. One more thing I wanted to show is show debug. This is what I was talking about in the PPT there. Debug RX. This is debug. You enable it like this: debug DB RX table and then route. And you, when you say show debug, it would show what is updated for what. I mean the DB RX and the route. So if you want to see the updates, you can see like this: show debug buffer module DB, then say reverse. So these are the updates. These are the OVS DB updates. As you can see that the last update is quite back, which is not now, where the DB is updated before. This was an upsert. So let's say show clock. This is around 7. If you can see, this is very old. It's 1 hour before. So there are no updates, which means there is no change in the change in the state of any of them, any of the tables. Now, as you can see, the stale part timer has expired of 300 seconds, and I'm seeing no updates after this, which means that there are no stale entries that got deleted. You can dump using this command and check whether there is any stale entries that got deleted after that. There is no stale entry that got cleared, so it means that all of the entries are received and those are marked valid. Now let's stop this. As you can see, 4397 packet transmitted and received. Here also it's 0% loss with Wi-Fi route, and here 4396 both received and transmitted, 0% packet loss. This is via /32 route. So there's no packet loss. So this is how EVPN GR works. That's all I have. Thank you.
Thank you very much, Swati. Really appreciate that demonstration showing that, well, even if the process is restarted, you see there is absolutely no impact on the data plane.